Hello, you're welcome to a new tutorial. So today we are going to implement how we can build a simple chatbot in Python. So I'm going to show you how you can build your own Python using the NLTK library. So we're going to make use of the NLTK library and the sklearn library as well. So without taking too much of our time, let's run through the code one by one. The first thing we need to do is we need to import our libraries. So we import the NLTK library, we import the warnings tier vectorizer, which is these are all the libraries that we need to import. So these are everything that we have here. So now let me run this cell. So now we are going to use the NLTK server to download all the corporal, that is to have access to the server. So we're going to we're going to use the popular. So let's run this cell. I think this shouldn't take much time because I have it downloaded already. Right, is it okay? So this is downloaded. So now we're going to read in our data. That is the data that we want to use with the for this particular code. We're going to bring it in. So what we're going to do is we're going to use the open. Okay, let's use the open to open the data that we have. Sorry, name of data is data.txt. So include other argument to this right now. So let's read in this data. So we use the f.read. So now, after we read in this data, we need to convert it to a lower case. So let's convert it using the .lower method. So I'm going to run the cell. I think I have an error somewhere. It's from errors, right? So the data that is going to be used is actually a data from Wikipedia. So we just went to Wikipedia, download different data that deals with chatbots. So this is what we're going to use to train, and then after we use this data, we're going to be asking our bots questions related to that particular data. So now we are going to move to the tokenization aspects. So we are done with the data, that is, we already brought in our data. So now we need to move to the tokenization aspects. Tokenization in NLTK actually means you're trying to convert possibly a string of words into list of tokens. And then when we're talking about list of tokens, we have sentence tokenization. We also have word tokenizer. So for the sentence tokenizer in tokenization is actually used to convert any kind of word to list of, that is, any kind of sentence to list of sentences. So, and as well as words, the word tokenizer is used to convert to list of words. That is, we can extract words out of it. So we're going to make use of both the sentence tokenizer and the word tokenizer with the data that we brought in. So let me tokenization. So now we're going to use the nltk.send tokenize. Okay, let's do that. Let's name it send tokenize. So make use of the, okay, let's use this as sentence tokens. So we use the nltk.send tokenizer. Then we use our data, and as well as the word tokenizer as well. And we also use the data. So now we are going to run the cell. I think I use tokenizer instead of tokenize. Right, so we have the send tokenize and the word tokenize as well. So now we're going to move to the preprocessing part. We're going to be making use of the stemming and the lemmatization. So, but we're going to discuss what each of these terms means in NLTK. Whenever we're talking about the stemming means we are trying to convert or reduce any kind of words to the base form, or possibly you reduce it to the you convert it to the root or the base form, just like we mentioned. So let's say for an instance, we have something like, okay, let's use the word stemming itself. We have the stemming, we have the stemmed, and we have the stemmatization. So the root or the base word for all these words is referred to as the stem. That is, the stem is the base word for each of these three words. So now let's move to the lemmatization. Lemmatization is also the same meaning with stemming, but the actual difference or the main difference between the stemming and the lemmatization is the stemming is usually used to find it actually brings up non-existing words, but the lemmatization usually brings up the actual words. So when we are talking about stemming and lemmatization, the main difference between these two is stemming gives you non-existing word, whereby lemmatization gives you the actual words. So these are just the two different meanings between stemming and lemmatization itself. So here we're going to make use of the lemmatization. We won't make use of the stemming, since stemming gives us non-existing word. So we're going to use the lemmatization, which is just straightforward. So let's define our lemma nltk.stem.wordnet lemmatizer. So now I already defined the instance for this nltk.stem wordnet lemmatizer here. So now let's define a function which are going to use to convert any of the words that we pass in through this preprocessing form. So let's define a function and name it. Let's use maybe lem tokens. Let's use lem tokens straightforward, and as put in a value. So now what we're going to do is we're going to look through any of the words that pass into this function. So let's say let's use this particular way for tokens. Let's make these tokens. So we're going to make use of the lemma here. So lemmatize. Then we'll pass in our token. So we need to return this. So now we're already putting any word that is coming from here is going to pass in through the word. We're going to make use of the lemma instance that we define here. So we first looping through all the words, then we pass it through this particular instance. So now we also need to remove punctuation. So we already defined the punctuation. That is, we wanted to remove this particular thing from our text. So now we also need to define one more function as well. So we need to define nice. So here is where we are going to be passing our value. Sorry. So this is where we're going to be passing our text. So we're going to make use of the function that we defined earlier, which is the len tokens. So we use the NLTK word tokenize. So convert our text to lower. that is using this particular argument that we pass in. So slower. Then we also translate. Then we use this particular remove punctuation text that we define here. So let me just copy it, paste it inside. So now we already use the lemmatization library, whereby we use our word tokenize, we convert our text to lower, then we pass in our text using this. So we can call this function whenever we have each of the word that we'll be putting in. So now I'm going to run this cell as well. So now what I need to do now is I need to define some simple data here. Probably let me just define something like the what they call it, my bots, and be able to recognize just like a simple data. So I'm going to define it under here. So you can refer to this, let's refer to it as keywords matching. Okay, let me just copy my data here. So I have something like a greeting input and response. So maybe I send hello or hi or any kind of greeting to the bot. It should be able to reply me with any of these responses that I defined here. So let's move forward. So we're going to write a new function for this. So this is not using any NLTK thing. It's just we're going to make use of the random library, whereby it can pick any of these words using the random dot choice to pick any of them at random. So let's define, let's say maybe sentence. A word we look through the sentence. First split it and look through it. So after I say if this particular word, that is the if word, convert it to lowercase. So we are now going to check if this word is in the word greeting input. Okay. So if this is in the greeting input, it should return, then let's say random dot choice words matching. That's what we do here. So we're going to move further and use the main NLTK library, whereby we go further to use the vectorizer. We also use the cosine similarity. So after the preprocessing parts, we need to move to the back of words, or just like I mentioned, like we use the vectorizer, cosine similarity. So what I'm going to say is we're not going to make use of the bag of words. So the reason why we're not going to make use of that is because the main bag of word itself, what it actually does is you have a particular word, let's say maybe hello, I, greetings. So these words are going to be converted to numbers because NLTK, anything you're passing, you're going to pass through it, it should be numbers, so it doesn't recognize anything like text. So we're going to convert all these particular words to numbers, but using a bag of words, the main problem with bag of words is it actually bring up highly frequent words. So we have more words. Let's say you have the, or let's use something like maybe I in a particular document, and it occurs for a, let's say maybe it occurs for 1,000 times. So that's what is going to calculate for you using a bag of words. So we're going to make use of another approach which is more better than the bag of words. Using the TF-IDF approach, we're going to rescale the frequency of words by how often they appear in all documents. So we're going to make use of the TF-IDF approach rather than using a bag of words. So that's what we're going to do. So after we are done using the TF-IDF approach thing, then we move to the cosine similarity, whereby we check for how similar words or vectors are to each other. So now let's define another function. Let's call it response. I'm passing user response. Okay, let's use this. Okay, let's define something like a bot, like an empty string. Then now we're going to use the send tokenize that we have here. So let's make it send tokes that we have over there. I think I'm making a mistake. Let me change this to send tokens. Okay, so that's cool. So send tokens. Then we use the append with the user response. Okay, so now we're going to make use of the tf-idf that I mentioned now. So we call it tf-idf. Let's use vec. Then is equal to, because we already import this from the sklen. If we go up over here, we use the sklen feature extraction.test. So we imported it. So we use the tf-idf vectorizer. Check what I'm typing, see if it's correct. So tf-idf vectorizer. So we pass in, use the tokenizer. What we're going to do now is we are trying to use the tokenizer with the vectorizer. So what we're telling this tf-idf, they are the words that already been lemmatized. So we're going to use the function that we define over here. That is this lem normalize that we define here. So we're going to pass it through lem normalize. So now we're going to call the fit transform from the tf-idf library. So let's name this maybe tf-idf. So we're going to use this variable here. Okay. And we call the fit transform. So we're going to use the sent tokens that we have here, which is the user response. We're going to pass, it's more like we are passing through each and every words that we send to our bot. So it is passing through one stage and the other, whereby we pre-process, we do all those kind of things and all. So now we pass in the send tokens, which is the user response that we have over here. So after we are done, we need to move to the cosine similarity. So let's define, okay, let's do browse is equal to. So you know we already imported the cosine similarity library, same as from the sklen. So let's check from up. So we have the sklen metrics pairwise. So we imported the cosine similarity. So we're going to call the flatten method on it. So before that, let's do idx a value, which is then we do add salt. Let's take the -2. So as well, let's flatten this particular value. So flatten. Then now we're going to sort, right? So we still have a few more things to do. So let's use request. So we use the flat as is a variable. So now any value that is coming from the response that we have here, that is the results. So let's do if this is equal to 0. So that's how we're going to know the what is bringing in. So if this is equal to 0, so we want our bot to give us a response. So it's going to tell you I don't understand you. But now, okay, let's return our response. Let's say return bot response. And as well, we need to have an else. So this is just to avoid a code from breaking, because for instance, probably I'm passing through a particular text doesn't understand, this code is going to break. So that's why we have to use this, that is passing through all this I don't understand you. We are going to use the else part, that is if this is not equal to 0. So our bot response should be okay. So we're going to return this value. I think my Jupyter is giving me okay, let me do this. I don't know why it's removing these values. So I'm going to return bot response. Right. So now we're done with the preprocessing. I will move forward to using the TF-IDF vectorizer and also the cosine similarity. So this is whereby we handle the bot response, whereby we send in any kind of text. Bot will recognize what we're trying to send by using the data that we provided. So it's going to give you the response through through the data. So now we're going to test our bots, which is the next line of code that we're going to use. So we're going to test our bot to see how well it understands what we defined to it. So now let's move to the part. So let me do a print. Whereby I'm going to name my bot. I'm going to name him John. So I say hi, which is more like the initiation part, which is the first thing you're going to see. My name is John. I will answer any question related to chatbots and AI. Right. So what we're going to do next is we're going to, okay, let's use a while loop, and let's define flag is equal to true, whereby our code run continuously. So now we're going to use let's define the user response as the inputs before we start calling our function. So yeah, this is the user response by converting it to lowercase. Right. So remember earlier I defined a greetings function. So I'm going to use this greeting function. This is just making use of the random dot choice. So we're going to use this over here. So we're going to use if greetings, that is if any of the word I sent to you through the user response. So let's first check if this, just to avoid that code from breaking. For instance, probably I didn't send anything or my message is empty. So this is what it should do. So set greeting, that is I'm making use that particular function, calling the function now. So we set greeting, we pass it the user response as well. Okay. So I already passed in the user response. So it first check if this is not equal to none. So it's going to use the user response. That is, we call that function. So what the function is doing is it checks any of our word that we pass through in, then it first splits. Then after it has splitted, then it's going to convert to lowercase. Then we use the random dot choice to pick our response. So this is what this code is going to do. So we define an else over here as well. So we print else to run again. Print response. So we're calling the response function here as well, which is from what we defined over here. So this particular one is using our data. We use the user response, that is the input. We pass in the input inside here. Yep. So I think that should be all. So what we've done here is we just do like a simple initiation. Then we define flag is equal to true. And okay, let's define another flag is equal to true here. So our code runs continuously. So we define another flag is equal to true here. So we do input, which is what I'm going to be sending in. So it converts this my input to a lowercase. Then I'm using the greetings function that I defined over here, which is using random.choice. And this particular one is whereby our data has been cleaned, that's going through lemmatization, TF-IDF, then the cosine similarity, whereby it can be able to pick a response for the bots. So okay, let's run this. I don't think I ran this cell earlier, so let me run it. So we have a particular error here. I think it's from this return. Okay, so let's run this. So let's run this as well. Now let's test our code. So let me send a greeting. Let's say hello. Me hi. So what I need to do is what is chatbots? Running. Let's see what is artificial intelligence. Okay. So chatbots. Okay. Now what else can I say? Let me see what is machine learning. Capture that. Okay, so it captures that. So that is everything we have. So we can see we can train this data. I mean, we can train this to be much more better. So how we can train this to be much more better is providing a very large data, whereby bots can be able to capture everything that was sent to it. And for instance, whereby I use these greetings as random of choice, I can decide to pass it through this particular TF-IDF, whereby I use the cosine similarity and all. So this is the end of this tutorial. I hope were able to learn how we can build our own chatbots. So if there's any question, please send them to the comment box. I will reply to each and every of your questions. So I would love to see you next time.